Hello, 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 hello. Hope everyone is doing well. Hope all is good with people and everyone's in good health. Everyone's staying sane. I'm sure people are getting kind of antsy just being in the house all day, but I hope you're finding some stuff to do. I am going to go over, I'm going to send a couple videos out and then I will go and give the actual chapter 10 test. So yeah, this chapter is a little bit tough, right? You get sort of used to it, but it's not the easiest. So I think we'll do another Google Hangout as well. So let me go and in the meantime go over number 13, which is a paired T test for the mean difference, right? Mdiff is what we would say. It's a paired T test for the mean difference. All right, so let's take a look here. Let's go capture main screen, and we are good, okay? All right, let's see. I can't get through my day without coffee is a common statement from many college students. They assume the benefits of coffee include staying awake during lectures and remaining more alert during exams and tests. Students in a statistics class designed an experiment to measure the memory retention with and without drinking a cup of coffee 1 hour before a test. This experiment took place on 2 different days in the same week, Monday and Wednesday. 10 students were used. Each student received no coffee or 1 cup of coffee 1 hour before the test on a particular day. The test consisted of a series of words flashed on a screen, after which the student had to write down as many of the words as possible. On the other day, each student received a different amount of coffee, none or 1 cup. One of the researchers suggested that all the subjects in the experiment drink no coffee on Monday's test and then 1 cup of coffee for Wednesday's test. Explain to the researcher why this is a bad idea and suggest a better method of deciding when each receives the 2 treatments. Well, just before we get into the answer, why is that a bad idea? Well, you're obviously going to be more comfortable with the test on Wednesday, right? So that's going to be a confounding variable, right, which could affect your study. You don't want that, okay? The variable that you want to affect the study is the coffee drink, the amount of coffee that you drink, right? That's what we're trying to see. So right here, I'm saying students may improve from Monday to Wednesday because they have already performed the test. A better way to decide when each subject receives the treatment is to randomize the treatment, right? That's the key right there. Randomize the treatment, okay? Right there. It looks like I'm crossing that out, sorry. Get rid of that. All right, we want to randomize the treatment right here, okay? No problem, okay? We will right here randomly assign half of the subjects to receive a cup on Monday. The other half will receive no cup on Monday. Then the opposite treatment will be given to each subject on Wednesday, right? Okay. So half the subjects will receive coffee on Monday. The other half will receive no coffee on Monday. Then we're going to switch it around on Wednesday. Those people that had coffee on Monday will not have coffee on Wednesday. Those people that didn't have coffee on Monday will have coffee on Wednesday. All right. So keyword there is randomize the treatment, random assignment, as you know. Okay, let's go to part B. The researchers actually used the better method of deciding which subject receives the 2 treatments that you identified in part A. For each subject, the number of words recalled when drinking no coffee and when drinking 1 coffee is recorded in the table. So we have this table right here, and we're checking like how many words were recalled from this test that we're giving, right? When we flash the words on the screen. We're carrying out an appropriate test to determine whether there's convincing evidence that drinking coffee improves memory on average for students like ones in this study. Okay, so right here, notice what I did, and I'll get to this in a second. I made a separate column of mean difference, right? Because this is a paired, this is paired data, right? You have one subject that gets both treatments. So in this case, that's going to be right here, a paired t-test for mean difference. All right, so we're going to do a t-test, right? First of all, we just have to do our state. Our null is that the mean difference equals 0, that there's no difference between coffee drinkers and non-coffee drinkers, okay? And right here, the alternative is the mean difference is greater than 0, okay? So if I'm saying greater than 0, that must mean that I did, the way that I set this up is I did right here, coffee minus not coffee, right? Because our alternative is to try to show that coffee increases your retention, right? For the words that are flashed on the screen. So I said that's where Mdiff equals the true mean difference, coffee minus no coffee, in the number of words flashed on the screen, recalled by students like those in the study who received 1 cup of coffee and no cup of coffee. Not the best English right there. I would have actually said on the screen, recalled by those who received. Here's how I would actually just say that a little bit better. Okay. So in the number of words, so what did I say? In the number of words flashed on the screen, recalled by students who received one cup of coffee and no coffee. So flashed on the screen, recalled by students who received 1 cup of coffee and no cup of coffee. Like the students in the study. So right here, flashed on the screen, recalled by students like the ones in the study who received 1 cup of coffee and no coffee. All right, actually, maybe just say right here, instead of doing what I just did right there, words on the screen recalled by students like the ones in the study who received 1 cup of coffee and no cup of coffee. All right, so I'm just going to go and just say right here, students like the ones in the study. There we go. That's better. Who received 1 cup of coffee and no coffee. Okay, good enough. All right, so what do I have to actually put right here? All right, right here, I'm putting right here, we will use alpha equals 0.05. Okay, sorry, this got cut off a little bit right here. Let me just rewrite that. Okay. Plan. Random. The treatments were randomly assigned. Check, right? So we're good. The treatments were indeed randomly assigned. 10%. So if you notice in this section, a lot of times we didn't use 10%. 10% is only to be used when you take a random sample. When you do sampling right here, in this case, it was not random sampling. It was this one statistics class, right? We did a random assignment, but we did not do random sampling. 10%, remember, is about the fact that you can sample without replacement. It means the sample is less than 10% of the actual population, but there is no sample. So we ignored that. Normal large sample, n equals 10 is not greater or equal to 10. So we had to do a dot plot. Okay, so I did a dot plot. So that's when right here, I said, oh, okay, I have to go and do another column that's mean difference, right? And I subtracted, in this case, right? 25 minus 24, 31 minus 30, 23 minus 22, 24 minus 24, etc. So it's going to give us 1, 1, 1, 0, 1, 2, 2, 0, 0, 2. And then I went and plotted that, right? In this case, I look right here. I have 1, 2, 3 zeros. I have 1, 2, 3, 4 ones. 1, 2, 3, 4. And I have 3 twos, right? 1, 2, 3. And then right here, I look at this. Obviously, there's no strong skewness or any obvious outliers at all. So I'm going to write right here, the dot plot shows no strong skewness or any obvious outliers. Okay. Paired T test for mean difference. Yeah, you can mention this to the end of plan or the beginning of plan, but just make sure you do tell what type of test this is. This is a paired T test for Mdiff, and we already defined what Mdiff is. Okay, do. So how did I get that? What did I do? All right, so let me show you what I did exactly. Okay, I went up here. I took out my calculator. I pressed the on button. I went to stat. I went to edit. And what I did is I entered in for Mdiff all these values. 1, 1, 1, 0, 1, 2, 2, 0, 0, 2, right? 1, 1, 1, 0, 1, 2, 2, and 0, 0, 2. All good. Then I went to stat. I went to tests. In this case, we're just doing a t-test, right? We only have one column. We only have basically, we don't have two separate columns in this case. We have one column. It's the mean difference, right? You just subtracted it. So we're just going to go right to t-test. And we went to data, right? Because this is data we entered in. The null is, of course, 0, right? If you can see, there it is right there. The null is 0, if you recall. Okay, list is obviously L1 frequency 1, and our alternative is mean difference greater than 0. So that's why I'm putting right there greater than 0. And I'm going to go down to calculate. All right, I did it a little differently than the book because the book actually did the mean difference is less than 0, and they switched it around. That, no cup minus 1 cup. So we got the same p-value, so that's all that matters. As long as you define, then you're okay. All right, so right here, here's our the statistics that we get right here. Our T score is 3.87. Looks like our p-value is 0.0019. The sample mean is 1. The sample standard deviation is 0.816. All right, and n value of 10. So our degrees of freedom is going to be 10 minus 1, which is 9. So let's go down. And right here, yep, I have it set up. This is all that's required. T value is 3.873. So why is the p-value low if you think about this? And you don't have to draw this, but hang on. Sorry. If you think about this right here, all right, what does this mean right here? All right, our T value right here is 3.873. All right, well, that's 1, 2, 3, even almost 4 standard deviations away. That's just at the real right-hand corner right there, okay? If you think about that. So that's why the p-value is so low, 0.0019, okay? And degrees of freedom, n equals 10, remember, if you recall. So the degrees of freedom, 10 minus 1 is 9. All right, the sample mean difference is 1. Sample standard deviation is 0.816, okay? Not required, but interesting to know, okay? Now, conclusion. Because the p-value equals 0.0019 is less than alpha equals 0.05. So the p-value is low, we will reject H sub O. There is convincing evidence that the true mean difference in word recall, coffee minus coffee, is greater than 0 for students like those in this study, right? Okay, so we found convincing evidence because the p-value was low. Right here, the p-value is the probability of your sample statistic being true given that your null hypothesis is true. Okay, so that's a very low probability, so that's why we're getting rid of that null and we're going with the alternative. Okay, all good, and that was it for that particular problem. All right, I will go on to another one. Hope this helped. Okay, have a good day.